All right, welcome. My name is Ryan Hoger. I'm with Temperature Equipment Corporation, and I will be working with you guys for the next hour to hour and a half on the International Energy Conservation Code. We did market this as a 1 hour topic. It's going to end up being an hour and a half. Many of you guys kept typing me questions all week long on email asking, are you going to cover this? Are you going to cover that? Are you going to cover this? So I kept adding more things into the discussion. If you have to leave us after the first hour, that's totally cool. We understand because that's what we promised you. You'll still get your PDHs if that's what you need. And all the things that people ask for extra, I put those towards the end of the day. So we'll still cover all the stuff we said we're going to cover. There'll just be an extra half an hour for those that want to stay. For those that do need PDHs, when you register, there has been a question asking if you're in Illinois or Wisconsin PE and need a PDH certificate. If you said yes to that question, and if you answer the quiz questions that pop up every 10 minutes here on the webinar, and you answer them correctly, obviously, you'll be eligible to get a PDH certificate. If you didn't do that, or if you answer them all with completely wrong answers, and then obviously you'll fail and you won't get your certificate. They're not challenging hard questions. They're just to verify that you're actually there and alive, so I can prove to someone later if I have to. All right, so with that being said, before we jump in, I just want to mention for those of you that don't know, on our website, tecmungo.com, when you click on training, other than seeing a tiny picture of me, we have classroom training on there. If you're interested in coming to us here in the Midwest and taking classes with us, there's just tons and tons of topics. There's also recorded webinars like the one we're watching now, or that we will be watching once it is recorded. And there are thousands and thousands and thousands of hours on there. And then there's our new, as of a year and a half ago or so, our YouTube channel, which is short clip type stuff. Right, so really quick type, 10-minute type topics. So that's just so you're aware of it in case you should be interested in learning more about other stuff. With that, we're going to jump into the code. All right, cool. Everybody should see on their screen the IECC 2018. We are going to be focusing on HVAC. That means we're going to ignore lighting, we're going to ignore the building envelope, we're going to ignore service water, we're going to ignore refrigeration, and anything else that's covered in the code. We just can't do everything, right? There's plenty of places to learn about that stuff. If you're interested, let me know, or check out the CDAC website. Those folks have good stuff on there. But we're going to stay on the HVAC path today. We'll start off with some general discussion. We'll do a little bit of residential, and then we'll spend the rest of our time on commercial stuff. As we go, I will try to point out to you stuff that is different from 2015 to 2018 version, because that's what many of you are obviously interested in, is the changes. So I'll try to point that out as we go too. We're a highly regulated industry. There's all kinds of stuff going on. The Department of Energy has lots of new rules, both residentially and commercially, as related to HVAC. And in addition to that kind of stuff, we have codes. Codes are enforced at the municipal level in our state in Illinois here. Whereas Department of Energy rules are enforced at the manufacturing level. And we'll discuss a couple of those as they intertwine with the code things we're talking about today. I'll just give you the brief history on the code stuff. Most of you know here in Illinois, since 2006, we have been on the International Energy Conservation Code system. Prior to that, we did not have a statewide energy code. We are now on an automatic adoption. So every 3 years when the code comes out, it automatically triggers an adoption policy for Illinois. And then barring a few little discussion points and amendments, things get adopted pretty much every 3 years. So we'll be adopting the 2018 code this year in 2019. And then we'll have 3 years of that code, and then the cycle will repeat itself. Residentially, there are a few states that are a little bit ahead of us on the code cycle, specifically Nevada and California. But then once we go live with the new code, we'll be pretty much on par with them. Residentially speaking. Commercially, pretty much the same story, right? So there are states in the Midwest that are on the current code as us, 2015, specifically Wisconsin and Michigan are, but we'll be going ahead of them a little bit further. So what that means for you is that you'll be the first state in the Midwest with the new code, which means you get to have all of the learning curve, right? And by you, I mean we, right? Because I'm stuck in this with you guys. Someone typed in a question already, and I'll just mention it. This is going to be recorded. So for people in your office that couldn't watch, or a coworker or whatever, you will get an automatic link in a couple hours after the webinar that you could share with them if you wanted to. Or you can use the exact same link you registered at. That link will also go to the recording in the future. All right, so what's going on with our state? Up until a couple days ago, we were expecting the new code to go live on March 1st. So for you guys that were super excited about the new code in 4 days, 3 days, you're lucky. There's a break, right? The state is now looking at probably May 1st as the code adoption for the 2018. So you get a little 2-month breather before you have to go live with the new code. That date is not yet set in stone. Legally speaking, it could be as early as April 9th that the code goes into effect, but it's more likely that they'll just wait till the next clean month, which would be May 1st. We'll keep you guys abreast of changes as that occurs, but that is the most current thing as of this morning. Other than that, other states, like I said, in the Midwest are on the 2015 or older versions. We're the first state, Illinois, will be going to the 2018 version. We'll be doing that both residentially and commercially. In Illinois, we adopt both of them simultaneously. In some states, that is not the case. In some states, they do either one or the other, but we do both at the same time. If you go to the State Capital Development Board website, you'll see information on the 2015 code and various amendments for that. The 2018 section of the website is useless. There's nothing on there yet that is useful to you. It's all stuff that's over a year old. So you will not find anything helpful there in that regard. But once they do adopt amendments to the code, assuming they do amend it again for Illinois, you will find it on that particular website at that super long link at the bottom. And I can also send that to you guys later if you need it to. The CDAC website you will find to be much more useful. CDAC is a University of Illinois group, kind of a private/public combo deal. And they're very good about tracking the code. They have part responsibility to do that now as of a couple years ago. And their website now was updated just in the past day or two to reflect the May 1st probable date as well. You'll also find some free training stuff on that website. If you're interested in learning about lighting as related to the code, you'll find stuff on there. Just general stuff you'll find on there. So that's a good site to have reference to as well. Historically, the code's been getting more and more strict. Residential is on the top in this graph. Commercial is on the bottom. For years, we'd have the same code, 7, 8, 10 years at a crack. Nothing would change. But now all the residential and commercial standards, International Energy Conservation Code, and 90.1 and 90.2 are all kind of on 3-year automatic adoption cycles. So they're constantly getting amended and adopted every 3 years. And you can see the energy usage is going down, 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 and down. For you guys that do residential work, you'll be happy to note here that there's not really any significant difference in the amount of energy saving requirements between 2015, where my mouse is at. I think you guys could probably see that. 2015 and the 2018. There are some changes, some things you got to pay attention to, but not a significant jump in energy difference. As far as commercial goes, that's based on 90.1 as far as the tracking purposes go. So 2013 ASHRAE would be the same as 2015 IECC. That's why that's a flat line there. So we're looking at a 52 to 48 difference in terms of energy intensity usage. So there are a few more changes on the commercial side than we have on the residential side, which is one of the reasons we'll spend more time on that. And I did not clear off all my little weird circles. I feel like John Madden with the big highlighter thing here. All right, so with that being said, when does the code apply? Which actually someone, Lance, typed in that question, so that's good timing, Lance. The code applies pretty much all the time. There's differences between residential and commercial buildings. Commercial buildings are buildings that are not residential, or residential buildings that are either 3 or 4 stories in height, depending on where you're at. If you're in Chicago, it's 4 stories and up becomes commercial, even if it's condos. And in the suburbs and rest of the state, 3 stories and up, condos become commercial, right? Other than that, residential is what it says, single family housing and small condo and apartments. And commercial is everything else, including large high-rise residential. Some folks have the feeling that the code only applies to new construction. That is very far from the truth. It applies to absolutely everything. So all the work you're doing, whether it's new construction, retrofit, renovations, the code is in effect. Starting with the 2015 version, they did come up with an existing buildings chapter. Instead of making you do everything in the code book, you don't have to do everything. So you go to this chapter to see what you have to do. But for you guys that are on the mechanical side, don't even bother, because once you read it, you'll realize you have to do everything. All the unique exceptions to existing buildings are like roofing related stuff, and HVAC, it'll pretty much keep telling you do everything, right? So for example, if we pop zoom a few up here, if you're doing additions to the building, you have to comply with section C403. That is the entire mechanical section. If you're doing alterations, you have to comply with section C403. That is the whole mechanical section. And then for whatever reason, they even point out that you have to do the economizers, because apparently that kept coming up as a question. If I just alter something, do I have to do the economizers? Yes, dude, you got to do all of section C403. What about if I'm doing repairs, renovations, alterations? When you start digging into that, you don't have to do all of section C403. If I'm just changing out, I don't know, a fan motor on an air handling system, I don't have to make the whole air handler and the whole system comply with code. But the new motor that I put in, that should comply with code. Or if I change out the VFD should be able to do what's needed to comply with code. So the general premise is, and the easiest way to think about it, whatever you touch, that new thing needs to comply with code. But the other old things in the building don't have to comply. If you got 10 rooftop units and you change out 3 of them, the 3 new rooftops have to comply, the old 7 ones don't, right? So whatever you're touching, the new thing has to comply. There are some additional exceptions there. I don't know if you could see it. There's a historic building section. So if you're in that status, then you have a method of not complying if necessary, and it requires approval from your building code official. That doesn't usually affect HVAC stuff, although it can. That's usually more visual stuff that affects. By the way, when you guys are looking at your code book, assuming you buy it or download it, you'll notice these little black bars on the side. I got 1 on the left and I got 4 on the right. Those black bars tell you in the code book something changed from this version to the last. So in this case, this is the 2018 book. So those 2 sentences right there changed from the 2015 to the 2018 book. It may be something significant. It may not be. In the case of this one where it says prescriptive compliance, the reason it's highlighted with the black bar is because the section numbers changed, not necessarily the wording. In other cases, you'll see a giant black bar down the whole page. That means the whole page is new. All right, so keep that in mind as you're looking at your book. If you're trying to figure out, is this something new or something that I had to do last time anyway, if you weren't sure. All right, moving along. We're going to have our first quiz question for you guys that need PDHs. If you don't need PDHs, you are welcome to fill out the quiz question for fun, because quizzes are in fact fun as long as you're not being graded. So the first question, which will be the energy code in Illinois starting in May? And I'll launch that quiz question and I'll give you guys, 30 seconds to answer that. So hopefully you can all see it on there and hopefully you're all answering. It looks like you are. I'm going to use this moment to point out to you guys, if you are in your office with 10 engineers watching this up on the big monitor and more than one of you is expecting PDH credits, if only one of you is filling out quizzes, only one of you is going to get a PDH certificate. If you'd rather sit in the room with your coworkers and watch it, open up the same webinar on your GoToWebinar phone app, and you can answer the quiz questions there. Just mute it, obviously, while you're watching it on the big screen with your coworkers and heckling me. Let's see if we have any questions anybody typed in. Tina asked, so you can reuse HVAC equipment that may not comply with the current, hang on, this got cut off, may not comply with the current energy code. So our question is, can you reuse equipment? Usually you can. So if you decided you're going to go into a space and it used to be an office and now it's going to be a classroom and you want to keep the existing inefficient air handler, you could do that. If you start changing the system, then you may be required, like, oh, it's not the same air handler. We're going to take this off and add this and move this and we're going to swap the condensing unit. Now all of a sudden that's a different discussion. But if you're just going to reuse it as it is and you're not going to touch it, then you're fine. If you change the occupancy of the building, the purpose occupancy of the building, sometimes codes will also kick into effect for that, additional codes. You have to go back and change stuff. Tina also asked about, what about reusing supply ductwork from a non-compliant RTU? Yes, you can reuse that ductwork, but if you change the ductwork, we add a new branch run. Now that new branch run will have to comply with the duct-related code things that we'll talk about later on. A few of you guys have typed your answer in to the question chat box, and that will not get you any credit in any way. you have to do it through the quiz thing on the screen. I will leave it up there for 10 more seconds so you can click the right spot. Specifically, I'm talking to Ming and James. All right, so I'm going to close this poll in 5, 4, 3, 2, 1. And 90% of you got the answer correct, which is International Energy Conservation Code 2018. All right, moving on. Residential stuff. So let's do that for the next 15 minutes, then we can go commercial the rest of the way here. Residential has not a lot of changes, which makes it easy to talk about, assuming you were already complying with code. You have to put a programmable thermostat in. You have to do that for all systems. There used to be an exception in 2012 and earlier for radiant floor systems. That exception is gone. So now you even have to put a programmable stat on a radiant floor, which is stupid, but that's the way it is. So every system needs a programmable thermostat. You need to set it for 70 on heating or less and 78 or higher on cooling. Then the occupants can do whatever they want later on, but that's their initial starting point. If they have a boiler system, you have to have hot water boiler outdoor air temperature reset, right? That's very common. On condensing boilers, it's pretty much standard. On non-condensing boilers, you'll have to add those extra controls typically. But you have to reset the boiler water temperature. Instead of always providing 180, you have to reset it lower as temperature gets more mild outside. If you have snow melt or ice melt systems, those need to be controlled as well. Unfortunately, there are many of those that end up running wild because they're put on a switch and then someone forgets to turn them back off. So you have to have sensors to control that. Specifically, you have to look at outdoor air temperature. If it's above 40 degrees, no snow melt system turn on. If the pavement is above 50, no snow melt turn on. And if there's no precipitation being sensed, no snow melt can turn on. Right? Duct systems residentially. If you're going to have the duct systems in the attic, both the supply and the return need to be insulated to R8. And then any ductwork that's in a crawl space needs to be insulated to R6. All ductwork must be sealed. That's not optional. It doesn't force you to use a specific sealing method. So you could use mastic. You could use UL foil tape. You could weld it if you wanted to. You can use AeroSeal, right? Any of these system scenarios would comply, but you do have to seal all of your ductwork. And the method to do that is covered in the International Mechanical Code if you're doing a condo building, and it's covered in the International Residential Code if you're doing a single-family type home or a non-high-rise. Ducts not only have to be sealed, but sometimes they have to be tested. The simple way to read this entire page worth of language is if your ductwork goes outside the conditioned building thermal envelope at any point in time, then the ductwork must be sealed and air leak tested. Right? So we pressurize the ductwork and measure how much CFM is leaking out of the ductwork. If you don't want to do that pressure test, do not put your ductwork outside the thermal envelope or do a really good job of sealing it up. Those are your two choices. The tightness that you're required to have, if you look down at the bottom of the page, and by the way, I'm not going to read you guys all these code sections because that would be boring as hell. They're just up here, so if you ask me a question, we can quickly reference something, but I'm just going to be highlighting stuff. I'm not going to read you paragraphs. If you're testing during rough-in, meaning the furnace and air handler is not yet installed, then you're allowed 3 CFM of leakage for every 100 square foot of home that they have. And if it's after the furnace isn't already installed, then you're allowed up to 4 because they're giving you a little bit extra because the furnace cabinet will have some level of leakage associated with it. Right? Those numbers did not change from last year. If you keep everything inside the envelope, you don't have to do it. The thing that did change on this particular section is that you no longer have to do an air duct leakage test on any of your ductwork that is serving an HRV or ERV. If your HRV and ERV is ducted into your furnace system, you would still have to do the test on the furnace ductwork, but you wouldn't have to test the outdoor air intake and exhaust section of the ERV. It's a pretty minor change, but it is a change. There is a really big change on residential, and this is it right here. There are two completely new sections in the code that didn't even exist prior. One of those is for ducts buried within ceiling insulation. So if you want to put your ductwork in the attic, which, by the way, most of the codes are doing as much as they can to force you not to put things in the attic, both for combustion safety and energy reasons. But if you feel that's necessary and you have to do it for your scenario, if you want to put the ducts in the attic, the ductwork has to be under the ceiling insulation. And if you start reading the language here, you still have to do the R8 on the ductwork, like I mentioned previously. But then additionally, you have to have R19 of regular insulation above the R8 duct insulation and R19 below it as well. So you have to completely encapsulate it in insulation, essentially. They're really trying to find ways to get you to stop putting ductwork in the attic because it's one of the biggest energy wasters out there. Between the leakage of the ductwork and the insulation, it is definitely a problem. For your ducts that are in a conditioned space, there is some additional language on that as well. If you're going to condition this attic cavity, if you will, the duct system shall be completely within the envelope, both from an air barrier standpoint and a thermal standpoint, so insulation and leakage. And then the ducts should still have to be buried in the insulation. And it goes on to continue that the air handler has to be within the envelopes. You can't have your air handler just sitting in the attic. You got to basically build a room around it and insulate and seal the room. So don't put stuff in an open, vented attic. That is kind of the new theme of that. So that's a little bit of a change from prior. Oh, and then for this scenario with these ducts in the conditioned space running through there, you're now cut in half. Instead of 3 CFM per 100 square feet, it's down to 1.5 CFM per square feet. If you want to put the ductwork in the ceiling insulation. Mechanical piping systems still need to be insulated. There is no big difference there. So based on the temperatures they're giving you for most of your boiler systems, you got to insulate the return and supply pipes. And in some cases, depending on how you interpret those temperatures up top there, you may have to start insulating your both your AC lines instead of just one of them. It takes quite a bit of insulation, half insulation for your typical Armaflex to get up to an R3, which is what the code requires. But there's no change on that from the 2015. Still got to do load calcs. There's no change there. You guys have all heard me complain about things being improperly sized in our industry and being oversized specifically. So you got to do the load calcs. You got to do them with ACA Manual J. And then in addition to ACA Manual J, which is the load calc, you have to use ACA Manual S, which is sizing the equipment to match the load calc. So you do have to do both of those still, and there's no option out of that. If you look at ACA Manual J, just for point of argument, and we pick O'Hare because that's what we're pretty much close to, the heating design temperature for O'Hare, according to ACA Manual J, is 2 degrees. You cannot design your system for energy code compliance to be a 0-degree system. You can't design it for -10. You cannot design it for the -26-degree polar vortex day. By the way, most of your furnaces capped up on those days because they're so grossly oversized anyway. And then on the cooling side, 89 is your design point for residential there if you're at O'Hare Airport. And most of you guys understand why that is. From an energy standpoint, we spend very little time at low load and very little time at high load. So we need to really focus on the middle temperatures. So sizing something for -10 and 95-degree temperatures is not really doing us any favors in terms of energy or in terms of equipment longevity or anything else for that matter. All right, quiz question number 2 for those playing along. True or false? Residential duct sealing is mandatory per IECC 2018. I'll give you a few seconds while I go and read the other questions you guys typed in for me. Lance is asking when ASHRAE 90.1 applies. For residential, it doesn't apply at all. For commercial, it will, and I'll explain that in about 5 minutes. Lance will go through when 90.1 comes into effect. Curtis is asking if crawl spaces and attics are in the envelope. Maybe, maybe not. Depends. So to be inside the envelope, you have to be both in the air barrier envelope, which means where you're sealing the home structure, and you have to be within the thermal envelope, which means where you're insulating the home structure. So in a typical vented attic, that would not be in the thermal envelope, right? Vented attic meaning you have the vents on the outside soffit and you have the rid vent on top. That is outdoors. Your attic is literally outside, right? If your attic is inside the thermal envelope, instead of sealing and insulating the floor of your attic, you would seal and insulate the roof of the attic, right? And then if you went up in your attic in the wintertime, instead of it being like 20 degrees up there, it would be like 80 degrees up there. That's how you would know it's inside the thermal envelope. Keith is asking, how does one design to 2018 when most municipalities are back on 2009 or 2012 in regards to the IMC? So in our state, as Keith probably well knows, our energy code, as well as our plumbing code for that matter, are statewide codes, but our mechanical code, there is no statewide code. So many municipalities have their own. And you're kind of just stuck. You have to comply with everything, as you probably know already, Keith. You already know the answer, I'm sure. You have to comply with the 2018 energy code for the state, while simultaneously complying with whatever the mechanical code is for the local municipality that you're working in. In most cases, there's not a conflict. If you want to give me a specific conflict you're running into, Keith, where the energy code from 2018 is fighting the mechanical code from 2012, we could try to figure out the correct answer for that scenario. All right, so back on our quiz question, I realized that I did not answer everybody's questions, but there's like hundreds of them coming in, so I'm just grabbing a few of them. The answer to this question is obviously true for our poll question. You're on the 2018 code for residential duct sealing. So you do have to seal your residential ducts. And 89% of you got that correct. All right, moving on. Last thing on residential, and then we'll go to the commercial side. Whole house mechanical ventilation is required by the energy code, which sounds weird, but because the envelope requirements of the energy code are so strict, the concern is that there's not enough fresh air for people, so a mechanical related code item got stuck into the energy code. And this is not new from the prior year. However, there is a slight difference, and that is that the HRV used to be part of the HVAC equipment exception, and now instead they have their own line item in the table down below. That's really the only difference there. So if you are doing your ventilation with an HRV, ERV, inline fan, or just a bunch of exhaust fans running, which is stupid, don't do that. But if you did, those fan systems have to meet their efficiencies in that table down below. If you're going to use your HVAC equipment, meaning your furnace, fan coil, air handler, as your distributor of ventilation air from outdoors, then that system has to have an ECM motor. You cannot do it with an inefficient PSC motor, because that motor is going to be running basically all the time, so they want it to be more efficient than the standard default motor would be. In that regard, that problem is going to go away really soon, because as most of you know, unrelated to energy code, the Department of Energy is requiring the manufacturers of furnaces, starting this July, to stop using PSC motors. So the default motor is going to end up being an ECM. The inexpensive, low-end, entry-level motor will be an electrically commutated motor. Right? PSCs will go away. Now, if you have a PSC motor that was built prior to July 3rd, 2019, and you want to install it in September, you can do that, right? Unless you're in this scenario I just mentioned here, then you would not be able to, obviously. All right. The 2018 amendments to the Illinois Code are not yet published, as I mentioned earlier. I expect them to be pretty similar to 2015. I'm not going to go through these in detail right now, but one of those amendments residentially is how much fresh air ventilation you have to be bringing into a building based on the square footage and number of bedrooms that you have. All right, so we'll save that for a follow-up day when they actually release the 2018 amendments. Quiz question number 3. Which of the following residential projects would require mechanical ventilation per IECC 2018? Your choices are A, new construction home, B, furnace repair, C, addition or home renovation, D, A and C, or E, B and C. I'll give you guys a few moments while I answer some more of these questions you typed in. Ron typed in some replacement units cannot go in attic. I'm not sure what the question was on that one, Ron. Oh, he followed up later on. If replacing existing systems in open attic, it now requires a room. Technically, the way the language is worded, that would be true, Ron. My guess is that your local municipality would probably give you an exception for a straight, say, furnace swap out in an attic. But yeah, if you read the language the way it's written, you would have to enclose that unit to get it inside the thermal envelope if it was not previously. What else? If I have exposed duct in the building, such as spiral duct, will it be required to be sealed? All ductwork has to be sealed, and it refers you to the mechanical or IRC on how it has to be sealed. So depending on residential versus commercial, depending on the type of joints, there'll be different rules on how it would have to be sealed. But yeah, it would definitely have to be sealed. All right. In regards to the quiz question, I never pressed launch, so that's why a bunch of you guys questioned back in. So all right, now the quiz question is open. My apologies. I guess I'll read 2 more questions while I do that. What happens when a PSC motor fails and needs to be replaced? I'm assuming that you're talking in regards to the Department of Energy rule that after July 3rd, furnaces have to come with a certain efficiency motor, which will prohibit PSCs. That will not affect replacement motors. Furnaces are what are being policed in that regard, not motors. So the furnace has to have a more efficient motor. But if you're just buying a motor off the shelf somewhere and you want to put it in something that already exists, you could still do that, Mike. And then all the other things you guys typed in were that I'm stupid and should have put up the poll question. You guys said it nicer than that, but okay, I think that was all the, holy cow, that was a lot of them. Okay, so I'm going to close this question in 5, 4, 3, 2, 1. Those of you that chose D, which would be A and C, new construction home, yes. Addition or home renovation, yes. B would not be included, so a simple furnace repair you would not have to do anything on. You just repair the motor or the gas valve or the thermostat or whatever the thing was. All right, so with that being said, 93% of you got it correct. All right, let's do commercial stuff. For you guys that tuned in a little bit late, this was supposed to be a 1-hour thing originally. Now it'll be an hour and a half. However, you can still get your PDH if you're here for that first hour. I'm going to cover all the things we promised in that first hour. The extra half an hour is going to cover all the extra things you guys emailed me about this week and wanted to talk about. So you get bonus stuff, but you don't have to stay longer if you don't want to. All right, so in terms of the code compliance, there are 3 different ways to comply with code on a commercial building. Number 1 is you can do ASHRAE 90.1. Do whatever it says in ASHRAE 90.1. In this case, it would be 90.1 2016 printing. If you do everything that's in there, you can take your IECC book, throw it in the trash, and never read it. Right? You can do the 90.1. It's approved compliance path. That's one choice. Or number 2 is you open up your green IECC 2018 book and do everything that it says in the book. Specifically, it's telling you here do sections 402 through 405. 403 is mechanical, by the way. Do 408, which we'll talk about here, and then do 406. So 407 is the only thing it's not forcing you to do, because 407 is actually option 3 on this page. Right? So you got to do everything in the book, essentially. The third way is I got something special. I can't comply with the window fenestration requirements they have, or the insulation, or I got a VRF system, so it makes it hard for me to do economizers. What do I do? Option number 3 is you can do an energy model. So basically, you energy model in software your building as if you did number 2 on the screen here, which is everything in the book. Then you energy model it the way you're going to build it, but you still have to do the mandatory sections, which are the things written on here. 402.5, 403.2, 403.3. Do the mandatory things, but the prescriptive things you don't have to do. You just have to energy model to prove you did 15% better than what would have happened, which is a pretty hard nut to crack. So usually when it goes to energy modeling strategies, people end up going to option number 1 and go the 90.1 compliance path instead. All right, sizing. No major changes here, so I'll blow through this really quick. Sizing is important just like it was residentially. You are required to do load calcs for commercial systems as well. This is one interesting one. You are not allowed to design the system to heat higher than 72 degrees, and you're not allowed to design the system to cool the indoor temperature below 75. You cannot cool below 75. You cannot design for 72 cooling or 73 cooling or anything like that. 75 is the lowest you can do. That is required and prescribed by the code for your interior design temperatures. You are not allowed to oversize the equipment. So you do your load calc, it comes up with 10 tons, you put a 10 ton in. Now it does, if you read the language here, allow you to round up to the nearest tonnage available. So if your tonnage is 9.7, they don't make a 9.7, you could round up to the 10 ton. And then if you have one piece of equipment that does both heating and cooling, such as a heat pump or a packaged gas rooftop unit, you can round up to the next size that covers you for both columns, heating and cooling. All right. But other than that, no upsizing allowed. There's a whole discussion we can have on why oversizing equipment is problematic for humidity control and all that stuff. Outdoor temperatures come into play as well. For this, as you saw a minute ago, we're sizing for ASHRAE standards instead of ACCA like we do on the residential side. So our outdoor temperatures are a little bit different. So if you're doing the 99% heating column, your outdoor temperature for O'Hare is 4 instead of 2. If you're doing the 99.6, which is what most of you do, -1 is your design temp. You cannot design for -5. You cannot design for -10. Those would not be allowed per the energy code. And on the cooling side, most of you guys are probably using the 0.4 column, which means your design temp is 91 outside. If you're using 1%, which is awesome, then you're at 89. Already talked about this column. You saw this before, but from an equipment standpoint, equipment is typically rated in EER, energy efficiency ratio, and that's always done at 95-degree day outside with a fully loaded piece of equipment. But as you saw a minute ago, it's never really 95 in Chicago. In fact, statistically, there's pretty much close to almost 0 hours. I mean, there's a few per year on average, but it's almost 0. So designing your system for that hottest day of the year to try to be efficient is kind of pointless. We really want to be efficient on all the more mild days of the year. How efficient is your cooling system when it's 85, 80, 75, 70 degrees outside? How efficient are we then? That's when it's more important. So because of that, the code recognizes that. We have a thing called IEER, Integrated Energy Efficiency Ratio. Basically, we do the full load EER test on the equipment right here. That's number A. We weight that 2%. Then we test it at 75, we test it at 50, we test it at 25% loaded at various outdoor ambient conditions, and we pretty much put all the weighting on the B and C column. We're basically saying you're going to run a lot at 75 and 50% loaded, not so much at 25 because in a lot of systems you're in economizer mode at that point, and hardly ever at full load either. So that's what EER is. It's testing this thing at 4 part load points and coming up with a combined number, if you will. The code for right now, this table right here I'm showing you is split system DX and packaged system DX non-heat pumps. There's like, I don't know, 11 pages of equipment tables like this. This is just the first page. So for larger commercial equipment, larger meaning over 5 tons, you have to do the EER and the IER requirement and satisfy both simultaneously. So I have to do the full load requirement and the part load requirement. The full load requirements for all these pretty much have not gone up in about 6 years. The part load all went up 3 years ago, but it has not changed for this particular table in the past year. In fact, most of the equipment efficiency has not changed. Furnaces went up a little bit commercially, and I think room air conditioner units, but heat pumps stayed the same, DX stayed the same, chillers stayed the same, cooling towers went up, right? So you got to look at the tables for whatever you're most interested in to see how much that changed. But for your everyday rooftop and split system DX systems, no change there from the previous code cycle. I just did a quick comparison on here for shits and giggles. The first column there is a entry level unit, like the least efficient unit that I could possibly buy. And then the one on the right is one that has a code compliant IEER and EER. And this little software tool helps me calculate the savings on there. And it is a whopping $27, 1% energy savings in Chicago. It is not very exciting at all in the Chicago market to force us into those levels. But hey, that's what it is. We got to comply with code, so be it. We'll use this software tool a couple times here today to illustrate some other stuff too, like economizers. I'm not going to give you a boring detailed discussion of how economizers work. If you don't know how they work at this point, let me know. Send you a video link or something like that. We have 3 main ways we control them. Dry bulb, which means just temperature only. Enthalpy, which is basically temperature and humidity, and differential enthalpy. Let me look at the supply air, the outside air intake. Let me look at the return air intake. Whichever one's cooler and drier, give me that one, right? Historically, we've set dry bulb economizers at a 55-degree changeover point. That means at 55 degrees and above, like we show with the red bar here, we're in economizer mode, and we're at compressor mode, and 55 degrees and below, we are in economizer mode. That's simple. This is a psychrometric chart. If you're not familiar with that, let me know. I'll send you a video link explaining how those charts work as well. They are super fun. No, seriously, they're really awesome and helpful tools over the years. From an economizer requirement, not a lot of changes in this discussion either. We still are required to have economizers at 54,000 BTUs cooling and up. That is for all cooling systems that have a fan. So that is not a rooftop rule, as many people seem to think it is. It has nothing to do with rooftops. Now, it applies to rooftops, but it also applies to split systems. It even applies if you put a residential furnace and a 5-ton air conditioner into a commercial building, you got to put an economizer on it. Or double check your load calc and see if you really only have a 4-ton system, because then you wouldn't necessarily need the economizer. So we still got to do these economizers on all these systems. If you don't want to do the economizer, you have a couple options. energy modeling in 90.1 or energy modeling in IECC, because this is a prescriptive requirement, not mandatory. Prescriptive means it's mandatory if I don't want to do energy modeling. That's what prescriptive basically means. There are some exceptions on when you don't have to do it. The exception list has shrunk since the prior year. Most of the exceptions don't apply to most of the things you do. Supermarkets exception, special process needs exception. So that's not normal things. The only one that's a normal thing is number 3, systems that operate less than 20 hours per week. And that's not even all that normal, but that does come up occasionally when you got like churches and stuff like that. Then you might not have to do an economizer. But other than that, when you're at 5 tons and up, you're doing an economizer. We are in climate zone 5A, so we are in green, and we are to the right of the AB line, so we are climate zone 5A when we're here in northern Illinois. For you guys tuning in from southern Illinois, you are 4A. I point that out on the map, and that map is used in a lot of different code books, not just the energy code. But I point that out on there because that determines what our set points have to be for the economizer. In climate zone 5A, our set point has to be 70 degrees, not the traditional 55. So that means if it's below 70 degrees, it's an economizer day. You got to start opening up that damper. If it's above 70 degrees, it's not an economizer day. If you want to do enthalpy, then we move the 70 to 75, and we also look at enthalpy, which is 28 BTUs is our cutoff point there. Right, so that line moves from the black line that every tech has set it up for 40 years, and it moves to where the yellow line is. The biggest problem with this, and for you guys that have been to any of our economizer classes and heard me whine about it, is this spot right here, which I call the triangle of death. Because that is where you get that day where it's cool enough to be a code-required economizer day because it's below 70, but it's like 90% humidity. Not a day that I really want that air. So that ends up being a problem, and I really want to avoid the triangle of death scenario. So because of that, we'll often go to enthalpy economizers, even on smaller units where we used to only put them on big units. Then the enthalpy line comes into play right here, and basically that triangle of death is now eliminated. I don't have to do economizer in that area. Just when it's below the enthalpy line and to the left of the 75 temperature line. So yeah, I got to do economizer on these days that I didn't have to do on a dry bulb one, but I trade that off for triangle of death days. I'm going to patent that triangle of death thing. All right. The economizer has to be integrated. That means you have to be able to use the compression in conjunction and simultaneously with the economizer damper. Once the economizer damper goes to fully 100% open, if you still have demand for more cooling, which is indicated by your thermostat requesting second stage of cooling, then you would then turn on the compressor with the economizer. That is required by code, and that is why we can tolerate economizer changeover points higher than 55 degrees. That's all explained in item number 1 there. Items number 2 and 3 have nothing to do with this discussion, and someone stuck them in the economizer section, and it bothers me, so I will talk about those later. All right, so that ends up being what my sequence looks like for you guys that are loving psych charts and following along there. If I go back to that same little software tool, I got those same 2 columns. I add a 3rd column, which is identical to the middle column code compliant model number, but I check the economizer box, and then I hit calculate on this little software tool. So instead of saving me 1%, it is now 7% savings to go from the entry-level unit that I could possibly get on the market to a code compliant with an economizer. So the economizer is saving me a lot more energy than just the straight-up improved cooling efficiency would. If you bring in fresh air into the building in extra quantity, you have to wait for the extra quantity of fresh air to get out. It goes without saying. And you have to have occupancy interlock on your economizer damper, and for that matter, on all the dampers in and out of your building. When the building is unoccupied, the dampers all need to be shut. So your economizer is a damper that's an intake to the building. So when the building is unoccupied, the economizer damper has to shut off for ventilation purposes. It could open for economizer mode, that's cool, but it's got to be shut for ventilation purposes. Most package rooftops, when you put them on the roof, default from the manufacturer. Every time they call for heating or cooling in the middle of the night, they open up their ventilation damper to bring fresh air in for a building that has no people, right? So the code is trying to prevent that. They're forcing you to do something extra, and I'll explain how we do that in a little bit. All the dampers to the building, including economizers, that have to be low leak dampers. So all your outside air intakes, including economizers, all your exhaust dampers have to be low leak dampers, which usually means that in addition to having seals on the edges and seals on the ends of the blades, they also move the gears outside the airstream. A lot of times they used to be in the airstream, but obviously if I have moving gears in the airstream, they can't be perfectly tight because they're moving, and hence air can leak by them. So now they move to the outside of the airstream. Not the outside of the rooftop, but the outside of the airstream. This has nothing to do with the energy code. I just pointed out when we talk about economizers. because a lot of people don't know. As of 3 years ago, you no longer need to have your outside air intake on a packaged rooftop unit in the city of Chicago be 15 feet away from the exhaust. It's got to still be 15 feet away from other exhaust sources, but it doesn't have to be 15 feet away from its own exhaust sources. Right? So if you got a rooftop unit on the roof by itself, there's nothing else there whatsoever, or there's nothing really remotely near it, it doesn't have to have any of these long ducts added onto it in the field like many of you had to do for decades. So that's no longer the case. Rooftops have plenty of issues with them. They don't get maintained very well. A lot of studies point to this. This particular study shows a 64% of rooftop units have an issue with the economizer. Damper is not operating, damper is bound up, the motor's laying on the ground instead of on the shaft, the damper position's too high, all those sorts of things. So because of that, 3 years ago in the code, they added economizer fault detection and diagnostics. This has not changed at all, but I'm just bringing it up quickly because many people are still doing it wrong. The economizer controller has to police itself for all these different potential faults. Then it has to notify the occupants of the fault. How does it notify the occupants of the fault? This is where the problem happens. So number 6 is where it explains how to do that. The unit shall be configured to report faults to a fault management application accessible for access by day-to-day operating or service personnel. What does that mean? That means the alarm message from the economizer controller when one of these bad things above happens, the alarm message has to go to the building automation system and then notify the building operator. It cannot just blink on the economizer controller that's buried in the rooftop where no one can see it. That's not good enough. It's got to be sent out to the building automation system. I don't have a building automation system. What do I do? That's fine. That's where the last part of the sentence comes in. Or enunciate locally on the zone thermostat. You can get a thermostat that'll display the economizer having a fault, right? So you can do that. You can put it on the BAS or on one of these thermostats that has an extra reporting feature to it, right? So it can send an alarm message to the stat itself. So that's an acceptable means of compliance. There are only a handful of stats that do that. The first time this came into code in Illinois, there was exactly 3 model numbers. Now there's like 8 or 9, right? But there's a pretty limited number of model numbers that have everything you need to comply with code. You have to have the fault detection diagnostic input to the stat from the economizer, and then you have to have an output on the stat that goes upstairs and tells the economizer when the thermostat is occupied. So to get a thermostat that does both of those is a little bit more challenging, but there are plenty of them on the market from all the major suppliers, Ventstar, Honeywell, etc. It's not that hard anymore. Other stuff in relation to controls, you have to have a 5-degree deadband between your heating and cooling set point. You cannot overlap heating and cooling set points. I don't know why you have to mention that. If you have to have a deadband, obviously they can't overlap. There's got to be a way for the occupant to temporarily override the thermostat instead of putting it in a permanent hold. You have to have adaptive intelligent recovery, so it automatically starts before the occupied period. That way, instead of starting it at 5 a.m. to be ready for 7 o'clock every morning, you just tell it 7 a.m. and it calculates how early to start, 6:15, 5:42, whatever it figures out it needs to do, and you're not always starting 2 hours early. As I mentioned, you have to have the ability to shut off the ventilation damper when there's nobody in the building. The thermostat's going to take care of that job if you don't have a BAS. And you have to display the fault alert on your thermostat or other control systems. Demand control ventilation, no change there. If you have a space that has a density of more than 25 people per 1,000 square foot, you need to use CO2-based demand control ventilation systems. There's some exceptions to that for very small systems, but on these larger systems, meeting rooms, gymnasiums, stuff like that, you're going to have to do it. If I add another column to that same exact chart, and this time I also check the CO2 box on there and hit submit, then I get an extra 6% savings. So 1% was for getting the code compliant efficiency IEER, 6% more for getting an economizer, and then another 6% on the demand ventilation on this particular example. This example was a 10-ton rooftop in an office building environment, just for argument's sake. You've probably seen this chart or ones like this. A lot of these systems that we have out in the field are not doing a lot of heating and cooling work. So what do I mean by that? All these hours in red down here are how many hours these packaged systems spend in the heating mode. And blue is how many hours they spend in the cooling mode. What was green was economizer mode. Purple was integrated economizer mode. Great, we got all that figured out. What is all this baby blue crap? All that baby blue crap is when I'm not doing heating, I'm not doing cooling, I'm not doing economizer, I'm not doing nothing, right? But my fan is still running because I use it for ventilation code compliance. So it's a lot of run hours with the fan doing something by itself with nothing else running. So it doesn't really matter if I have a super efficient cooling system or I have this great economizer I added. That's all fine and dandy. But when my fan's running 20 hours out of the day or whatever it's running, that's a lot of hours. So we got to start picking on the fan guys a little more. And that's where some of the code changes come into play here. This is by far, in my opinion, the biggest code change. And maybe I'm saying that because I work at an equipment distributor, so things that relate to equipment are more interesting to me. But this is by far the biggest code change. All of your systems that are 65,000 BTUs cooling and larger, DX systems right now I'm talking about, have to have at a minimum a 2-speed fan. This was supposed to go into the 2015 IECC. But as you guys know from talking to me about that 3 years ago, they accidentally, inadvertently, purposely, whatever you want to say, put it in the hydronic and zoning system section of the code, therefore making it only apply to hydronic or zoning systems, not to all systems. They have fixed that in the 2018 book and is now in its own section, so now it applies to everything. So all your DX systems that are 65,000 BTUs and larger, so basically anything more than 5 tons of cooling, have to have at a minimum a 2-speed fan. You could also have a variable speed fan, that's fine, because that would be more than 2 speeds, so that would also comply. If you have chilled water systems, then instead of looking at BTUs, it's based on horsepower. If you have a 1/4 horsepower motor or more, you need to have at least 2 fan speeds. So for small chilled water fan coils, that's going to be an ECM motor with multiple fan speed taps, and then for larger systems, that'll be a VFD. If you have systems that control space temperature by modulating airflow, then you have to have a modulating fan. What kind of systems control space temperature based on changing the airflow? That would be a zoning system, VAV, VVT, something like that. Your thermostat's telling the damper to open or close more. You're changing the airflow based on the temperature. That's what this section is for that I just highlighted right here. So if you have VAV or VVT, then you have to have a variable speed fan. A 2-speed fan is not good enough in those applications. So a 2-speed fan for all your traditional quote-unquote constant volume jobs, variable speed fan for all of your zoning airflow jobs. This is the typical sequence of a 2-speed fan. The 2-speed fan per the code language for both IECC and 90.1 only requires you to change the fan speed for cooling, not for heating. It's kind of weird. The reason for that is the Economizer controller. Nobody makes a simple Economizer controller right now that can do more than 2 minimum damper positions. And obviously, as I throttle the fan speed back for cooling purposes, it's going to change my ventilation airflow. So if I throttle it back to a 3rd different speed for heating, where do I get that ventilation minimum from when I only have 2 minimum positions to work with? So until that gets fixed, the heating won't get solved in this discussion. So if I'm at all my stages of cooling or any stages of heating, I'm at full airflow. But if I throttle back to only stage 1 cooling, then I go down to 66% of the airflow. Or if I go to ventilation only mode, which is a lot, I go to 66% of the airflow. If I do that same little simple tool, in this case I'm comparing a code compliant unit with an economizer. So I already did all the good stuff that I had to do for code to the exact same model number plus a 2-speed now code required fan. Right, so this is a 2015 code unit compared to essentially a 2018 code unit. 30% savings. Only thing I changed from this one to that one is I changed the fan speed control. 2-speed fan instead of 1-speed fan. Just by doing that, 30% savings because there's that many run hours of fan in most projects. It's a big deal, and that's why it's in the code now. And it's pretty easy to do. Every manufacturer has this. If they don't have this, they're mistaken, or they're just clueless because all the big players have it, right? I mean, obviously we do it better at TEC Carrier, obviously, but everybody can do it. There are rules for staging as well. If you have 75,000 BTUs of cooling or more, you're required to have a 2-stage unit. You cannot put in a, say, 7.5 ton or 10 ton single stage unit. That is not allowed. 2 stages minimum. Right? That's for energy reasons in here, but it also helps you significantly for comfort and dehumidification. Then additionally, item number 3, other DX units, including those that control space temperature by modulating airflow to the space, and once again, controlling space temperature by modulating airflow, that means VAV, VVT, airflow-based zone dampered systems. So as you put zone dampers in on the airflow and start throttling it back, you are now in this category. So now you have to have additional stages, meaning that you're going to have 3 or in case of larger systems, 4 stages of cooling. So 65,000 BTUs, that's basically more than 5 tons. If you're more than 5 tons, you're going to have 3 stages of cooling if you have zoning on it. Right? And then if you're more than 20 tons with zoning, you're going to have 4 stages of cooling. They don't really dictate to you how the stages have to be. It could be 4 compressors like I'm showing here. It could be a compressor with a digital scroll or a compressor with an inverter. There are different ways you can get that done, but you do have to have the capacity staging. What you can't do is use hot gas bypass. That does not count. And if you look up here on top, I should have highlighted it, but right there, hot gas bypass does not count as one of my 2, 3, or 4 stages as required by code. That's because hot gas bypass is not efficient at all. In fact, it is probably the least efficient way to control capacity. It's a good tool. It's important to help us with really low load scenarios, but it's not very efficient. Essentially, what happens in hot gas bypass, for those that don't know, you're basically grabbing, not basically, you are grabbing hot gas off the compressor, and instead of sending it where it's supposed to go, which is the condenser outside, we shove a portion of that back into the inlet of the evaporator to falsely load the system to make it run longer, which obviously is not energy efficient. It runs longer, helps dehumidify, controls capacity, but it's not efficient at all. It's the least efficient thing you could do. It is not allowed as complying with your integrated economizer or staging purposes. And then additionally, there's also other limits on it. If you're going to have hot gas bypass at all on any system, there's limitations on how much of it you can do. They're basically pushing you to have more stages instead of the hot gas bypass. All right, let's do quiz question 4 and 5. That way the people that have to leave at the end of the hour can do so, and the ones that want to hang out, awesome. So question number 4, and we'll do 4 and 5 right away. Which of the following are required on a typical 10-ton DX rooftop installation? Typical. What are required on a typical 10-ton DX rooftop installation? Are you required to have an economizer, fault detection and diagnostics on that economizer, 2 stages of cooling, staged air volume or VAV, or all of those things? Which of those do you have to do on a typical 10-ton unit? Was there any other questions people typed in? Let's see. Ashraf asks, and he just logged off, do hotel rooms require ventilation, which means ducting outside air to each room, or can we supply air to the main corridors? So that is not an energy code question. That would be a mechanical code question. Yes, hotel rooms do require ventilation air. Your methods of choosing how you distribute it, I'm not sure if you can still do corridor makeup or not. I believe that you still can, but that's definitely not in my expertise of energy code. Ming asks, no oversized equipment selection allowed, but we can put a safety factor in the load calc. Are you asking, are you allowed to do that? No. Are you asking if you could do that and get away with it? Probably. But you do not need a safety factor. Everybody, stop putting safety factors in your load calcs. It is why your equipment is double-sized. I'm not exaggerating. Every boiler is double-sized. Every chiller is double-sized. Every air handler is double-sized. Your furnace at your house is probably double-sized. I'm not even exaggerating. It's double-sized. You guys are putting, I'm saying you guys stereotypically of all designers, you're putting the safety factors on every one of the little answers on your software input for your load calc. Oh, well, I'll round off on this. I'll round off on that. And you're always rounding up. You're just putting all these little safety factors in. And then you add another safety factor at the end, and then you round up to the next whole size and you buy it from your supplier. So stop doing that. Lance asks, are you required to use snow and ice melt systems? No, you don't have to have snow and ice melt systems. They're not efficient at all, obviously. But if you are going to have one, then you have to have the controls that we mentioned before. All right, so I'm going to close this poll question and pop up the other one. The correct answer is E, all of the above. 96% of you got that one correct. All right. Last question, number 5. If a zoning system is applied to that same previous 10-ton rooftop example, which of the following is also required as a minimum? Do you have to do 3 stages of cooling? Do you have to do an ERV? Do you have to do DCV? Do you have to do A and B? Or do you have to do A and C? I'll let you guys answer that. I'll read 4 more questions, and then we'll go into some of the extra stuff we wanted to talk about today. John said safety factor is a good engineering practice. I'm not opposed to the safety factor in itself. I'm opposed to the multiple overlapping layers of safety factors. When you're doing a load calc, if you put a safety factor on each one of your inputs, because you don't know all the answers exactly, so you're kind of guessing on a lot of them, and then at the end you put another safety factor on, it starts getting a little bit overwhelming. Additionally, as a side discussion, all of the AHR rated equipment capacities you get from all your manufacturers, they can pretty much do more than they state they can do. Because what happens with those, the manufacturers don't test all those combos. They only test the ones that get requested for testing, right? And if they don't come within 5% of what they stated for HRI, then they get flagged and they have to test a bunch more. They don't want to test a bunch more. That's expensive. So they understate all the performance values in terms of the capacities. The load calc software, guys, there are hundreds of things that go into a load calc. The software questions most of them ask you are tens of questions. So they've already pre-guessed at lots of things, right? So there's also safety factor built into there. So if you got jobs where your equipment's undersized, I would love to see those jobs, but I bet you it's way less than 1% of the jobs. So John, safety factors make sense. I understand why they're there for other engineering disciplines like structural. In terms of HVAC, do not double, triple, quadruple up your safety factors. All right, let's finish this question off. All right, so last question, 3, 4, 5 seconds, gonna close it. And most of you got that wrong. You said A and C, which should be 3 stages of cooling and demand control ventilation. Demand control ventilation is not required in a typical 10-ton zoned unit. So only correct answer would be A, 3 stages of cooling. I'm not sure why so many of you said demand ventilation. That's kind of interesting. All right, let's go through a few more things here. A few more brand new things on the code. For you guys that have to log off, I get it, I understand. For you guys that can stay with us on some of the more exotic things, we'll talk about a few of them here. I'll answer the rest of the questions on the list and we'll get wrapped up. Dedicated outside air systems. I actually am going to read this one to you. Ventilation air heating control, so for heating, and this is a mandatory thing, so you have to do it for all scenarios, not just prescriptive, but also energy modeling. If you're doing ventilation air and providing it to multiple zone areas, and you're going to operate this unit in conjunction with your zone heating and cooling system. So when I read that, I'm thinking VRF, which is why I drew it out here. It could also be ductless mini splits, could be PTAC units, it could be that quarter makeup air example somebody had given me earlier, any one of those things. You shall not use heating or even heat recovery to raise the temperature above 60 degrees when the building does not, when majority of the zones need cooling. You can either look at the zone needs themselves through a DDC system, or you can use outdoor air as a surrogate for that, to estimate that. But 60 degrees is your maximum ventilation dedicated outside air unit supply temperature when you are in essentially cooling mode for the other systems in the building. ERVs, I won't explain how those work. Most of you guys get it. If not, we have an hour webinar on how ERVs work. Save a boatload of energy, great for applications that have a lot of outside air. When are they actually required by code? When they are required, they have to be 50% enthalpy effective. That means that all your ERVs have to be enthalpy ERVs. You cannot have a heat recovery ventilator, a sensible only energy recovery ventilator, and still get 50% of the total latent energy, or 50% of the total energy. So you have to do the latent and the sensible to get 50% of the total. So sensible only systems do not comply. You can still use them on situations that don't require an ERV at all, but once the code requires an ERV, it's going to have to be a latent recovery ERV. There are a whole table here I'll show you in a second on when you have to do this. There's 2 tables actually. The first one is for normal systems. The bottom table is for systems that operate all year. It says 8,000 hours per year. I realize there's 8,760. I'm assuming that if they wrote 8,760, you'd say, well, the system was down for maintenance for an hour, so I don't have to do it. So it's basically normal systems on top, 24/7 systems on the bottom. When we're in climate zone 5A, the way you read this here, if I start over at the far, I'll do it right here. The far right, 80% outside air. If 80% of my airflow comes from the outdoors and 20% from the return, then anything bigger than 120 CFM, I'm going to have an ERV. And then it tiers down from there all the way down to a 10% outside air system. If it had a 26,000 CFM supply fan, which would be very large, I would have to have an ERV. So those are all the scenarios I have to have an ERV if it's a regular system. If it's a 24/7 operating system, then instead what ends up happening, except for my thing's not clicking, I don't know why, I'll just use this. Climate zone 5A, it's pretty much every system. There's a little slight out here of some very small amounts of CFM. I believe that came about because people like with a BP gas station or a Walgreens were like, what the heck, man, we're a tiny little building. All right, so they got some little exceptions there. But other than that, you're going to have to do it for those 24/7 operation systems. Anything that's 24/7 probably has to have an ERV. Boiler side of the equation, once you get above 1 million BTUs of boiler, you can no longer use a single boiler. You'll need 3 boilers, right? So you can have 333, 333, 333. Or you could have one single boiler that was modulating and it had a 3-to-1 or better turn-down ratio. That would also be allowed. And then as the BTUs of the boiler plant go up, then you either need more boilers or you need better turn-down ratio on a modulating boiler. Either way, it can accomplish the goal. But you can't take out one old million BTU boiler and put in another brand new million BTU on-off boiler. That's not allowed. So you got to go modulating, which usually means condensing, or you have to go with multiple smaller boilers and stage them. For both chillers and boilers, the pumps have to be isolated, so we don't flow water through a chiller or boiler that's not running. Right, so the pump has to shut off, the valve has to close. Do not flow water on the piece of equipment that's not running. If your chillers are in series, you are allowed to flow water through them, obviously because they are in fact in series, and there's no other way to do that other than a giant bypass line. You have to have outside air reset control on the boiler plant, just like we did residentially. That's required commercially as well for the same exact reasons. You cannot mix fluids that have been heated and cooled, right? So I can't have my chiller and boiler have a common return or anything weird like that. It's kind of weird they even have to say that in the code, but so be it. You have to have automatic controls to sequence the boilers. So you can't do it manually. You can't have a guy whose job it is to turn the boilers on. It's got to be automated. And then if any of your boilers that are 500,000 BTUs and up have to have multiple stages or have a modulating burner, even if it's a single boiler. So this section over here is newer. The stuff on the right was already in the code, and there kind of is a little bit of an overlap between them. Other stuff for mandatory control rules, just like residential, we got rules on when you have to have automated controls for snow melt. You can't let them be turned on manually. If you got heat trace tape on pipes in unconditioned spaces, they have to be automated with a temperature thermostat. If you're going to heat anything outside, like a patio or something like that, or a beer garden, you have to have motion occupancy type sensors on those so you don't heat them all the time, only when people are actually there. Plus, they have to be radiant-based heating systems to begin with. You cannot heat air outside. That's illegal. And if you have an ERV, you have to have dampers and controls to bypass the ERV on Economizer days, because the ERV would actually hurt you in that case. This section is brand new as well. Vestibules. It's in the mechanical section, and you wouldn't think vestibules would be a mechanical thing, but this is discussing how they get heated and cooled. So you are not allowed to heat or cool outside of a certain range. So you can only heat up to a maximum of 60 degrees in the vestibule, and you can only cool down to a minimum of 85 degrees in the vestibule. So you can't have a vestibule entryway and keep it at 72 degrees. That's not allowed, right? It's supposed to be a buffer between the outdoors and the indoors. It's not supposed to be a fully conditioned space. So that's the rules on that. Additionally, you have to disable the heat whenever it's warmer than 45 degrees outside. So those are new controls you have to have on these vestibule heaters. Additional controls on hydronic systems. I mentioned you got to do the automatic reset for boilers on outdoor air temperature. Same thing with the chillers. You have to have a reset on the chiller system. You can't run the same chill water temperature all year long. For HVAC, for process, you obviously could. But for HVAC, you got to change the water temperature. You can do it on any number of factors that you wish. They don't really care. You just have to do it. Now the rule for when you have to have a VFD on a pump is much lower. 2 horsepower pumps and larger need a VFD. We picked on the fan guys. Now we're picking on the pump guys. Same kind of idea. Pumps run all the time. Fans run all the time. Heating and cooling runs less. I mentioned the isolation valves when you're not using those pieces of equipment. If you have a 2-pipe changeover system, that's dumb. You should stop building buildings like that. But if you do, there's rules on how fast you can change them over. Minimum deadband of 15 degrees. For example, between 60 and 75 degrees. You can't do any heating or any cooling, no boiler, no chiller, between 60 and 75 degrees. Right? You have to disable both of them and let the system just float. So there's rules on that. Cooling towers have rules as well. The fan horsepower, if they total up for the cooling tower 5 horsepower or larger, you're going to have speed control on those. Just like we were picking on the blower fans, we're also picking on some of these outdoor fans. You can run it off of condensing pressure temperature, which is what we prefer on our chillers. You could also do it by leaving water temperature if you wish. If you have multiple fans in the same cooling tower, you have to ramp them up and down together. You do not stage them. Ramping them up and down together allows you to have the full surface area of heat exchange, which allows you to be more efficient in that regard. So running the fans at lower speed, let's say running 2 fans at 50% is better than having one at 100 and the other one off and being a big bypass flow. If you do water source heat pump jobs like we do in Chicago quite a bit, and you got a water source heat pump loop, you have to have a dead band of 20 degrees, a water temperature where you do not fire the boiler or the tower. So say, for example, between 55 and 70 degree water temperature, you cannot use the boiler or the tower. And you have to let the heat pumps just add and remove heat to the loop on their own. Right, that kind of thing. For VAV control systems, this one's weird. This one's not new. It came in the last code cycle as well. The pressure sensor used to be 2/3 down the duct. Now the pressure sensor has to be located wherever it has to be to give you a set point of exactly 1.2 inches of duct static pressure. I don't know why exactly they did that, but that's kind of the rule. It makes it really easy for the programmer. Program every job for 1.2, and then just have somebody else keep moving the probe to where it goes. But the problem is a lot of people put the probes too close to the fan, and in that case, the fan runs much higher than it needs to. So it needs to be further downstream. Technically, the best place to put it would be at the furthest worst duct run of VAV box, and if he has enough pressure, everybody else has enough pressure. But that's kind of hard to figure out, which is where the 2/3 rule came into play. But now the rule is you got to put it wherever 1.2 inches of duct static is expected, and that might be much further than 2/3 down the duct. The static pressure is not a constant number either. It's 1.2 inches, and then it has to reset lower as zones change. So if I'm looking at all my zones on a DDC system and nobody's 100% open, obviously I'm giving you too much air. I should give you less. So let's just say, for example, I have 10 zones and all 10 of them are less than 80% open on the damper. I'll drop my set point automatically from 1.2 down to 1.1 and see what happens. I'll drop it down to 1.0 and 0.9 until at some point one of my dampers goes wide open. Then I stop doing that, right? And if I can't satisfy him with him being wide open, I'll start raising the pressure back up. It's a pretty normal sequence that every control manufacturer has written before, and they can cut and paste it into their next job, but it is required by code. If you have fractional horsepower motors like on fan power boxes, or even small fan coils for that matter, on series fan power boxes, they have to be ECM because the fan is running a significant amount of hours. On parallel boxes, you don't have to have an ECM motor. You could if you wanted to, but you don't have to do that. But on series boxes, you do have to have that. And then additionally, in addition to resetting the static pressure of a VAV system, you also have to reset the supply air temperature, at least 25%. You can do that based on a surrogate of outdoor air temperature, which is dumb, or if you have DDC, you could do it based on the zone needs, which is smart. So if your set point is 55 degrees, 25% of the difference between supply temp and room air temperature would typically be 5 degrees. So I have to reset from 55 up towards 60. So as the zones as a group on average become cooler and cooler, I reset from 55 to 56 to 57.1 to 59 to eventually 60, or even a little bit more if I wanted to. Probably not much more than 62, or it's going to be really difficult to control dehumidification. Here is a change that's fairly important for guys to do control work. If you have DDC controls on your VAV system, which most of you do at this point, instead of the 30% minimum damper position before engaging supplemental heat, you now have to go down to 20%. VAV boxes with DDC controls have much tighter airflow control, and hence they can force us to have a lower airflow. So first, before you energize the supplemental heat in that zone, you have to throttle the cooling airflow back down to 20% of the airflow, or the ventilation required amount, whichever is obviously higher. Nothing else changed else on the VAV sequencing. Duct sealing, still required, no change there. Duct insulation, still required, no change there. So if you have supply or return ducts, you have to insulate them to R6 if they're in an unconditioned space. And if they actually go outside, literally outdoors, they have to be insulated to R12. I always get the question at this point, what about a return air plenum? A return air plenum is conditioned, so hence no extra insulation required. I would still insulate my supply ductwork for sweating reasons, but I would not bother insulating the return duct. For one, there is no return duct, it's a return plenum, right? And two, that little stub you have coming into the room, it's not going to be cold, so it's not going to sweat. But if you have a regular drop ceiling and a return duct running through it, and you don't condition that ceiling, then yes, you would need to insulate the return in addition to the supply. Ducts got to be sealed. Air handlers got to be sealed. Just like residential, we got to do all that. Residential, we had a pressure test if we went outside the thermal envelope. Commercial is different. We have to pressure test if we design the duct system to operate at 3 inches of static or higher. So we still have to seal low static systems, but we have to pressure test them for a certain leakage rate once they get above 3 inches of static. So I suggest you design your systems for 2.9 inches of static or less. Otherwise, it's going to be extraordinarily just an extra cost to test these things. Duct systems are really bad, as you probably know. They're very, very leaky. It's not uncommon for us to have jobs with 30–40% duct leakage. It's an everyday type of problem. It costs a lot of extra money. The biggest actual extra cost is actually exhaust fans. Exhaust fans are, I don't know if I put a stat on there. An exhaust fan with 20% leakage causes the fan power to increase 95%. And for you guys that know the affinity laws, the fan laws, you know that's a lot of money. So if you can seal up a lot of these systems, and exhaust fans are the worst because a lot of them have fairly leaky shafts, because who cares, it's exhaust, right? And the other problem is that they run all the time, nonstop, typically 24/7. So the money adds up pretty quick. But even VAV systems and rooftops and everybody else's ductwork is all pretty leaky as well. So you're going to see more and more rules on picking on the duct leakage. Right? We picked on the cooling guys. Now we're picking on the fan and pump guys. Next guys are probably going to get picked on will be the duct guys. Other stuff you'll see, in addition to that rooftop table I showed you, there's another, I think, 10 pages of equipment efficiency minimum requirements. There's pages for cooling towers, chillers, water source heat pumps, PTACs, VRF, everything. The ones that changed are room air units, cooling towers, and I think furnaces changed for commercial systems. Piping insulation requirements, fan efficiency requirements, buildings that are above a certain size. I think it's, I want to say off the top of my head, 400,000 BTUs of cooling or 600,000 of heating. Once you're above that size of building, you have to do commissioning and balancing required by code. The additional efficiency package, I wasn't going to talk about that, but this is one people asked about, so I'll briefly talk about it. Section C406. What this section is, it says, great, you did a good job. You did everything we required in the code book. Now, please do one more thing. You may pick from this list of 8 things. We don't care which one you do. You have to pick one extra thing to do. It used to be 2 or 3 things. Then it was 6, and now this year it's up to 8 different choices. The easiest one for most projects is number 2, reduced lighting power. That's usually the easiest one. However, when your architect says we're not doing that, we're doing the HVAC item number 1, you say, great, we can do that. Just know that it eliminates many of your system choices. For example, it eliminates rooftop units, gas-fired rooftop units. Because one of the things that's going to end up happening is you have to do 10% more efficient. And if you go 10% more efficient than an 80% efficient rooftop, that would be 88%. And nobody makes that, right? At least not in every single size. So it kind of eliminates certain kinds of equipment. If you're using little furnaces or you got a really efficient boiler plant, then you could do number 1. But if it's a rooftop job, you cannot do number 1. But you have to do one of these for every one of these projects. This was not something that was required for renovations, alterations, replacement, repairs. This is only required on new construction, right? Because when we read those other sections, it said do everything in C403, which is the mechanical section, which is great. It did not force us into C406, which is this extra thing. So this is more of a new construction thing, or I guess a total gut rehab teardown. In addition to the energy code requiring efficiencies, the DOE is also doing that. I mentioned to you on residential furnaces that rule changes in July. For rooftops, that rule changed last year. And for them, they specifically said you had to have a certain IEER that you had to get to. And this is that table that they specified. They didn't talk about EER. They didn't talk about economizers or anything else. Just you have to get to this IEER. Carrier, train, everybody stop building anything less than this IEER. Right? So you can't really buy stuff worse than this anymore. So if we compare these different rules, this is a gas-fired rooftop example for 5, 10, 15, and 25-ton units. Our new local code, 2018, this is what we required. The Department of Energy rules, this is what they require. And it's pretty much exactly the same for IEER, with the exception of that 12.6 versus 12.7 on the 10-ton. I don't know why they couldn't make it match, but that's like the only one I could find that's different. It's super weird. Energy Star finally got enhanced, and it's a little bit more efficient. For a while, it was worse than code, which defeats the purpose of having an Energy Star program. Now it is back above code. So if you go above and beyond code with your rooftop and package system choices, you can get Energy Star equipment, and in some cases that might help you get free money from some entities and so forth. Additionally, ComEd will incentivize you to do better than the code minimum, or at least do the code minimum. So they'll give you $10 per ton for every IEER you go above code, right? So if I put in a 12.6 10-ton IER unit, I will get a check for nothing. All right, if I put one that's 12.7, which I have to buy anyway because that's the worst one I could buy from the Department of Energy, great. They'll give me $10 per ton. It's a 10-ton unit. I'll get $100, right? If I put an Energy Star one, 13.8, that would be $1,200. 12.6 to 13.8 would be 12 times $10 a ton, right? So that would add up pretty quickly. So you can do that, and that's available to all ComEd customers that are eligible for the commercial rebate program. Then additionally, ComEd has another program specifically for small business customers. If you can hit these specific tiers of equipment, which by the way, if you look at them, they match up fairly decently to the Energy Star, at least for the 10 and 15 ton size, they will give you between $200 and $400 per ton, depending on certain things. They'll give you that, plus they'll actually give you extra money for a CO2 sensor as well, so you get even more money than $400. But they'll give you that. Let's just say you only got the $200 per ton. Great, $200 on a 10-ton unit, that's $2,000, right? So if I was on the regular program, I would have got $1,200 for that unit. On the small business program, I would have got $2,000 for the exact same piece of equipment, or more if I got more towards the 400. It depends. The 200 and 400 depends on the current life of the existing piece of equipment that they have. Right? Is it an early replacement, or is it dead on arrival, or dead on site? Why am I not clicking? All right. So the best thing you guys can do would be to educate people. If you want to be someone who complies with code, which you're required to do, but it's hard to do sometimes. I get it. People underbid you and don't do the right thing. The best thing you can do is educate your client. Say, hey, this is what the code requires. This is what needs to happen. If you're going to get other bids, make sure these dudes are complying with code. Because they're not complying with energy code, what other safety-related codes are they probably also skipping on? So if you want to be a code complier, which I'm assuming you do based on being on this webinar, you're probably going to have to call out some of your competitors for not doing it. I'm going to read off a few more questions here for you guys that had typed more stuff in. Let's see. Mark asked what program I was using for those little rooftop comparisons. It's a program called Invest. We actually have a rooftop class coming up for those that are interested. I can't type. We have a rooftop class coming up, and we'll go through that software in detail. We actually give that software to the students in the class. I'm going to cheat, and I'm going to type in RTU because I don't want to look through weeks and weeks worth of classes. So only look at rooftop classes. April 17th, if you come to that rooftop repair replacement class, we will give you that software, and we will show you how to use that software. Let's see. Steve asks, how is the distribution of air handled when airflow is reduced? For instance, a constant volume system that has reduced airflow, the space diffusers may dump. I'm assuming he's talking about requirement for staged air volume. Yes, that would be true. If you have poor diffusers that have that were selected with a bad ADP or API, whatever that, I can't remember the acronym is. We need more acronyms in my life. Which is the diffuser's ability to throw airflow out. If you selected them at a poor selection point, like many of them are, you'll have more dumping than you otherwise might have. That is true. And that would be something that you might want to suggest the customer fix with a better diffuser at the same time they are replacing the piece of equipment. Dan, from my own company, writes, but we have a 48 TCM series, which doesn't have SAV or VAV. So we have an exception? Yes, no? No. You can comply with the IER efficiency, and you can use it right now for code compliance with 2015, but that will not give you 2-speed fan control, so hence you will not comply starting in May with 2018 code. So you can all buy those from Dan for the next couple of months, and then you have to stop. I don't know what Dan's other question was on circuiting. Bruce asks, what if the unit is supplying only the first phase of a 2-phase remodel? I don't know what he's getting at there, and he logged off, it looks like. But if you're installing one unit for, I'm assuming in this case 2 units, those 2 units have to comply with code at the time they're permitted. So that's a good point as well. The point of the code you comply with, 2015 or 2018, is determined by when you get your permit, not by when you install the stuff. So let's say Illinois does go live on May 1st like they're expected to. You get your permit approved on April 10th. You are good under the current 2015 code, even though you might not put this stuff in until August. All right? But if you get your permit submitted and approved after May 1st, then you'd have to comply with the new code. That's how that would work. Same with residential. Curtis is asking if it's against the energy code to install unit heaters in residential garages. I don't believe that there's anything that would prohibit me from doing that. I think you can install it in the garage. But if you heat it above a certain temperature, we'll have to look at the code for that. Heat above a certain temperature, then all of a sudden the garage is going to have to be sealed and insulated like any other structure. So mildly heating it or spot heating it, like with an infrared heater, you turn on and off only when someone's there, you could do that. If you want to heat your garage up to 70 degrees and let it coast at 70 with your crappy ass garage door, then that's not going to work. Lance asks, ASHRAE 90.1 version that complies with 2018 compliance path is 2016. Yes, ASHRAE 2016 is the compliance path for IECC 2018 if you wish. The current 2015 IECC would reference back to 90.1 2013. So the ASHRAE version is 2 years, actually more like 18 months, but 2 years ahead of the IEC in all those cases. I didn't understand Rich's question about transfer air, so call me about that later. Joe asks if the IEC commercial requires air leakage thermal envelope testing. Joe, I don't know, because I was only focused on HVAC related things. I know residential does and has for the past 6 years. I don't know about commercial. I don't think that it does, but somebody mentioned that's coming down the pipe. I just don't know if it came down the pipe in the 2018 or the 2021. But we can go back and look at the code book. I don't pay attention to the non-HVAC things typically. What else? Other questions before I log off? Well, over 100 of you stuck through. Out of 300 people, over 100 of you stuck through for the extra half an hour, which is super awesome. I'm glad you guys got extra out of it. For those of you that required PDHs and you said you wanted PDHs, if you answered 3 of the 5 quiz questions correctly, you will, which is 80%, or rather 60%, excuse me, barely passing, then you will get a certificate. Normally I say like in a week, but with 300 people, it'll probably be a couple weeks. If for some reason you have an urgency and you have to reapply for your PE right now, let me know and we'll get it to you faster. Otherwise, the next couple weeks it'll trickle out to everybody as they type them up and grade them. Well, if there's no more questions, oh wait, there is more questions. Whole other page. God, you guys are. Matt said steam and water boils question mark, but then he logged off. So I don't know what he meant by that, but yes, there are rules for steam boilers and water boilers. Bernadette asked if the code eliminated the option for a 3-pipe system. That got eliminated a long time ago, probably like a decade ago or more. Does that also include 2-pipe, or is that still allowed as long as they're controlled? Yeah, so no 3-pipe systems. Lance asks, can you explain how to check compliance for IER and EER for package units and split systems? Package units, super easy. Split systems, super hard. There's 2 options. You can have your equipment supplier send you the quote-unquote submittal documentation illustrating the EER and IER. And that is quite frankly the easiest way, because then it puts the work on somebody else. And I realize that work's going on my coworkers, but they're good at it and they don't mind. The other thing you could do, I have up on here the AHRI website. You can look up the efficiency of any equipment that is tested or at least rated by AHRI. They don't test every single model, obviously. But for rooftop units and large commercial split systems, you go to commercial, then unitary large equipment, then AHRI rating conditions. So you'd go on here and you'd search for what you wanted, either by model number, or you can do a more advanced search and try to hone it in by efficiency or whatever. But if I just look at a specific model, just for argument's sake, hit search. If I knew what I wanted a Carrier 48HC. It's actually going to be a pretty big list. I probably should have did something less. But in any case, If I look at any one of these entries and there's 85 items that fall into that category, there's 14,974 systems loaded in the database. But if I look at these, this is the information that it shows, right? So here's my EER. If I scroll over a little bit more, there's my IER. So 12 EER, 13 IER for that very first one, right? Along with my BTU capacities and that kind of stuff. And then I can click on the little numbers over here, and it'll pull up a certificate. Or it'll pull it up on my other screen, and I'll drag it over for you because it went to where we didn't want it to go. And there's a certificate showing you the exact model number that's rated and the conditions, blah, 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 and the efficiencies. All right, so that's how that would work, or you can get it from your equipment supplier. Question about the ComEd rebate somebody had. So let's put that back up because that wasn't that far ago. He said, is it 10 IER or $100 per IER? It is $10 per point EER. So both of your answers are correct, I guess. If I go from 12.6 to 12.7, that would give me $10 per ton. If I go from 12.6 to 13.6, that would give me 10 times 10 for $100 per ton. That was confusing. Sorry about that. Jeff asked if you can still get a certificate when they didn't check the box. Yes, I'm going to make a note right here to go when I pull the report for them, change your answer to say, yes, you are a PE. By the way, if you guys need certificates for other reasons, we ask you if you're a PE, you need a certificate for that purpose. That's because we just have to do it that way. But if you need it for another purpose, you can just say, yes, you are, and get the certificate, and then you can use it for whatever you want. But the only thing we can guarantee is that it'll get you PDHs for Illinois and Wisconsin. But if you need it for some other program of your own choosing, then you're welcome to get a certificate and just submit it. Same question. Jeremy asked if there's going to be a recording. Yes, you will get a link with the recording that you could then share with someone else if you'd like to. Jeremy forgot to check the PDH box, so we'll put him on here. Any other questions before I log us off? All right, cool. Well, thank you guys for joining us, and thank you guys for that stayed on and for the little bit of the extra stuff. And we'll see you at the next topic.